Hey, welcome back. This lesson is event tick and input axis events. In this lesson, we're going to learn how to control the floor actor with our mouse input. To do this, we need to use input axis events. We're also going to learn how we can read the input values from our mouse. And we're also going to be taking a look at the event tick. Okay, so let's take a look at how we can make use of our mouse input. So let's head into our level blueprint. And instead of closing and reopening our level blueprint all the time, which is pretty annoying, we can actually just take this tab and we can dock it next to our level tab here, so we can just switch between them. So where do we find our mouse events? Well, let's come to an empty space on our graph and let's right click and let's come to input again, because we're dealing with input, but we're looking for some mouse input. So look, we have mouse events. When we double click here, we can see we've got events for the left mouse button for when you actually click it, and the right mouse button. But look, we have mouse X and mouse Y. So mouse X will be when we pan our mouse left and right, and mouse Y will be when we pan our mouse up and down. Let's get both of these events. So we'll right click again and come to input, mouse events, and then mouse Y. I'm going to move my mouse Y just a bit further down just so we can focus in on this mouse X here. So this event looks different to the input action events that we've been using, and this is because this event is an input axis event. Look, if we hover over this event with our mouse, it says this event provides the current value of the mouse X axis once per frame when input is enabled for the containing actor. So what this is saying is, wherever this event is, if it can receive input, in our case it's in the level blueprint and we can receive input because we've been using some input events already, it's telling us that this is going to update every frame and return the mouse X value. You might have heard of the terms frames per second or frame rate. This refers to how many images are being displayed on our screen per second, and we can view our frames per second by coming back to the level, and in the viewport we can click this arrow here and we can check show frames per second. Okay, so we can see that my frames per second are about 120 frames per second here, and so this means that the mouse X event is going to fire 120 times every second. And every time it fires, it's going to return the mouse X value in this axis value pin, which is a float. And a float, or a floating point, is a fractional value that has a decimal point and numerous values after it. So for example, this value could return 5.6789. Okay, and we can read the value and print it to our screen by using a print string again. We can right click and search for our print string. And look, when we click and drag this green float pin, we can plug it straight into the string input. And look, it says convert the float to a string. And it adds this node for the conversion, and we can hook up the execution pins together here. And then if we come back to our level and hit play, and if we click in the viewport and move our mouse, look, if we move it left, it goes negative, and if we move it right, it goes positive. Okay, so negative values for moving left and positive values for moving right. And the faster we move our mouse, or the further we move it, it's going to give us some higher values or lower values if we're moving left. So our mouse X event fires every frame, which means if we're running at 120 frames per second, this means the event executes 120 times per second. And so we have this axis value, which gives us the input of our mouse X movement. And we can read this value by connecting the float value to the input of a print string. And this means when we play the game, we can read the values. So let's take a look at using this event to control the role of our floor actor. So to do this, I'm going to remove my print string and the conversion for the float to a string. And then I'm going to select the floor reference we've got here and then shift select the add actor world rotation function. And if we hit Control W, we can duplicate this down and we can plug this to the execution pin of the mouse. Before plugging the axis value into this, look, we can see that we've still got the value of 5 on the roll. What happens if we hit play? Well, it's rolling it by 5 units every frame. Okay, but how can we plug this axis value into this? This pin here, we can hover over it. It says it's a rotator, which contains the roll, pitch, and yaw. And we can access the roll, pitch, and yaw individually by right-clicking on this pin and splitting this struct pin. Okay, now we have, look, the individual roll, pitch, and yaw, and their float values, which allows us to plug the axis value straight into the roll here. Now when we come back to our level and hit play, we can now roll our floor actor just by panning our mouse left and right. So I now have a challenge for you. Using what we've learned and using the mouse Y event, I want you to control the pitch of the floor actor. So pause the video here and give it a go, and when you're ready, come back to the lesson. Okay, so to control the pitch of the floor actor with our mouse Y event, we can duplicate this world rotation function, and we can hook up the mouse Y execution pin to this function, and we need to provide the target. So who is being rotated? Well, it's our floor reference, so we can use this here. And then we want to control the pitch, so we can plug the axis value straight into the pitch. And now when we come back to our level and hit play, we can roll and control the pitch with our mouse. But for me, the pitch is inverted. So how do we fix the inverted mouse situation here? Well, with our axis value, we can edit this before it goes into the pitch. Okay, we can just use some simple multiplication with this. If we drag this out and put in the star sign or asterisk, we can get a float multiplied by float. Okay, and if we multiply the value by -1, we will flip the value and invert it, and we can plug this result into the pitch. Okay, and now when we play the game, the floor actor pitches in the opposite direction and we can also roll. So this is looking good. But the more we pitch and roll the floor, you'll notice that the floor actor is offsetting on the yaw. It spins around a little. We will tackle that in the next lesson, but before we move on to the next lesson, I want to show you that there is a much easier way for us to rotate this actor with our mouse input. Let's come back to the level blueprint. I'm going to break the links on my mouse Y and mouse X events just to cut this off for now. And if you recall back when we first opened our level blueprint, we had an event begin play and an event tick that we removed. Let's bring the tick back. If we come below where we've just been adding our code, just to an empty space on the graph, if we right click and come to add event, we can get the event tick, and this is where we can also get the event begin play and a couple of others as well. But let's just bring the event tick back, and look, when we hover over this, it says this event is called every frame. Well, that sounds familiar because we are doing this on the mouse Y and mouse X events. So if we grab the floor reference and an add actor world rotation and duplicate it down with Control W, if we just hook this up to the tick and make sure we've got a value just in one of these, so I've got 5 in the roll. If I hit play, we can see that this is rolling every frame for 5 units every frame. Okay, so just like the behavior we had before. But how can we use the mouse X and mouse Y values with this? Well, we know we've got the axis values on these events. Okay, but if we right click anywhere, we can come to input again, and where we have mouse events, just underneath this we have mouse values. And look, if we double click here, we can get the mouse X and mouse Y values. So if we grab one of these, look, it's just giving us the float value. We don't need to call the event as well, because the event's doing the same thing as this tick here. It's calling every frame, and we have our mouse value. So really we're doing the same thing here, but only using one event. But we can also get the other mouse value, but before we do that, let's plug this into the world rotation. We need to split the struct, and then we can click and drag this into the roll. And now we can right click and come to input again, and then mouse values, and then mouse Y. And we can plug this in. But we also want to flip the value by using a float multiplied by float. We can use a star or asterisk to get this, and then set the value to -1 to flip it, and then we can plug this into the pitch. Okay, so look, we've done the exact same thing, but with only one event, so we've reduced our code. We no longer need our mouse X and Y events, so let's select all of these and remove them. And now when we play the game, we have the exact same setup as before, but with less code. Awesome! So we know that there's different ways to do the same thing inside of Blueprints. In the next lesson, we're going to code even further so we can fix this yaw offset issue we see when we rotate the floor. So I'll see you in the next lesson. Hello, welcome back to this lesson, which is getting and setting actor rotations. So we're going to be doing some more coding in Blueprints. We're going to take a look at how we can get the current rotation of our floor actor, and then using those values, we're going to set a new rotation that combines the input of our mouse. But this way will allow us to filter out the yaw rotation that will fix the yaw offset issue we see. And then we're going to wrap up this lesson by limiting the range of how far we can rotate the floor actor. Okay, so I'm currently playing the game, and I'm just going to roll the ball off our floor to begin with. So let's take a look at the floor. When we add pitch to the floor, and when we add roll, and then if we pitch the floor back and then roll it back, we can see that we've offset the whole floor actor on the yaw rotation. Okay, so when we combine the pitch and roll together, we have this annoying issue where we just keep rotating on the yaw. Okay, so this is going to be frustrating for the player. So let's take a look at fixing this problem. Let's come back into the level blueprint. We currently have it set up so that every frame we read our mouse X and Y values and add them to the rotation of our floor actor. And this add actor world rotation function, it's okay, it's been serving its purpose for us so far, but we need that little bit more control over our rotation values. So I'm just going to select this for now and remove it from the blueprint by hitting delete on my keyboard. And let's take a look at another way we can do this. If we drag out from the floor actor and come down to utilities and then transformation, look, this is where we got the add actor world rotation function here. So these are all add functions, but if we keep scrolling down, we come to some get functions, and look, we can get the actor rotation. And this has a rotator return value. If we right click on this, we can split it to gain access to the roll, pitch, and yaw. We can also right click on the float pin to recombine the struct back into a rotator. And there's another way that we can gain access to the roll, pitch, and yaw. If we drag out the rotator return value, we can see we have a break rotator that's suggested to us here. So we can select this and we can see we now have the roll, pitch, and yaw. So we're really doing the same thing here. So like I said, there's multiple ways we can do the same thing in Blueprints, but we're going to work with this way for now. But this is okay, we can get the active rotation values, that's great, but we can't set them with this function. So how do we do that? Well, we can drag out from the floor again, and we can scroll down to the utility section, and then transformation, and if we go past the add functions, and keep going past the get functions, we have some set functions, and look, we can set the actor rotation. Let's move this function over to the right, and we can see that this function is similar to the add actor world rotation. We definitely want to check the teleport physics because we want to teleport the physics state just like before. And we have the rotator pin on this function that allows us to set a new rotation. And we know that we can right click and split these rotator pins, but look, we can do something else here. We can click and drag out the rotator, and it suggests to us to make a rotator. And this gives us the ability to set the roll, pitch, and yaw. So for setting a new rotation, we know that we can get the current actor's rotation, and we can break this out to give us the individual current rotations of the roll, pitch, and yaw. We can set a new rotation for that actor using the set actor rotation, and we can individually set the roll, pitch, and yaw. So you're probably thinking, well, how does this help us? Well, we can apply our mouse input using some simple math between these nodes. So let's take a look at this. I'm just going to select my set and make nodes, and I'm just going to move them across and just down a bit so we've got a bit of space between these two nodes. And look, we've got this big blue line going across here. Let's neaten this up. Let's break the link on this target, and let's get the floor and duplicate it with Control W and just plug this in here just so it's a bit easier to read. So we get our actor rotation and we have our mouse X value. So the mouse X controls the roll, and we know we want to apply the mouse X to the roll. So if we drag out the mouse X return value, we can search for the addition sign to get a float, add float. And we can connect the roll into the second input to this to add these two values together. And with this pin on the right returning our new value, we can connect this into the roll on the make rotator. So we are now adding our mouse input to the roll rotation. So I have a challenge for you right now. I want you to take the mouse Y value and add it to the current pitch rotation of the floor actor. So pause the video here and give it a go, and then when you're ready, come back to the lesson and I will walk you through the process. So to do this, we want to take the current pitch rotation of our floor actor, and then with this we can drag it out and use a float, add float, just by searching for the addition sign here. Okay, and then with this we can use the mouse Y input to add these two values together. But remember, we invert the mouse Y value, so this is why we have this multiplication going on here. We can just plug this straight into here. I'm just going to move these across to get them closer, and then we can plug this into the pitch to make the new pitch. But look, we've also got the yaw here. Let's leave the yaw at 0 because this will constantly set the yaw to 0. And look what happens when we connect this together and hit play. So we can pitch forwards as usual, and we can pitch back, and we can roll left and right. But look, the more we apply this together, we are not offsetting this on the yaw value. But we still have an issue here. We can just pan our mouse right and we can keep flipping this all the way around. So let's take a look at limiting the rotation of how far we can rotate this floor actor. We can see how weird it is when we do this. So we want to limit the range of how far we can rotate our floor actor. Let's say, for example, we want to limit the range to -40 and +40. So we have these range of values. Well, to do this, we can clamp our pitch and roll values, and Blueprints allows us to do this very easily. So let's take a look at how we can do this. If we come back into our level blueprint, where we do our addition with our mouse values, we can drag out the return value from the addition, and we can come to the math category, and under the float section, because we're dealing with float math here, we can find a bunch of different math functions, and one of them is clamp float. So we can call this function, and look, we have a min and max value, so we can set a range of our values here. So we can put -40 and +40, and we can connect the return value straight into the roll. And we can do the same with the pitch by duplicating this with Control W while it's selected, and we can plug our addition value into this and then plug the return value into the pitch. Okay, so now this is looking good. If we come back to our level and hit play, when we add pitch to the floor, it will limit the rotation if we go too far, and the same for coming back on the pitch, and the same with the roll. So we have a much better solution for controlling our floor actor by adding and clamping our rotation values. But we've been using this floor actor the whole time, and in the next lesson we're going to take a look at creating our own maze. So when you're ready, jump on into the next lesson.